work. We started it a little bit towards the end of class yesterday. I would like you guys to spend a few minutes working on this right now. It is front and back. We're going to go over it here shortly. So start with this. So give yourself some time to do this, and then we're going to go over it, and we're going to move on to our concept map. All right, let's go ahead and talk about this. First question, we got some sodium nitrate plus some hydrogen chloride. Let's see here. Hey, Craiglow. What is this going to make?
Sodium chloride and hydrogen nitrate.
You got it, big dog. Here we go. Sodium chloride and hydrogen. Hey, Miss Lacker, does it make a difference if I write sodium chloride first or hydrogen nitrate first? No, it does not. Just like 3 plus 2 and 2 plus 3 are the same thing. Doesn't matter the order. Okay? Good. Hey, I don't know. Washburn. What does that arrow mean right here?
Equal.
Yeah, it's like the equal sign. What's its proper name? Do you remember?
Yield.
Yeah, it means yield. Or you could think of it as saying the words to produce. Or produces or something like that. Okay? Alrighty. Let's see here. Daniel, can you tell me where the reactants are in this equation?
Sodium nitrate and hydrogen chloride.
Love it. Yep. Everything before the big arrow. This won't always be two things exactly. The key idea is where is the big arrow? And everything before it is a reactant. Yep. And then, Daniel, what do we call these two? Yep, those are products because they are produced. So I'll put a P there for products, R there for reactants. Okay, not bad, not bad. Hey, Maddie Stickney, what does it mean for something to be soluble? What does that mean? It can dissolve, that's right. Are precipitates soluble? No, they're not. And that's why they formed in the first place. If they were soluble, when we pour those two solutions together, we wouldn't see anything happen because they would just stay dissolved. But because we see that solid form, we're like, oh, that must not be soluble. Okay? So please keep that in mind. So dissolving, yeah, precipitation not soluble. We'll go ahead and move past that. All right. Evie Blick Wiggins. I'll take 10 grams of whatever that is, plus 15 grams of this. How many grams do I have to have of this? Yes, I have to have the exact same mass before and after. It is impossible to do anything else. Okay? Let's see here. Reactants, products, we know where those are. Yeah, no, that's pretty good. That's pretty good. Is there anything else you want to talk about in this bell work? No, there's not. All right, let's go ahead and get to the concept map. I will be asking people questions about this periodically. Okay, so here's what I want to accomplish with the concept map. We've talked about so many terms and ideas. Physical property, chemical changes, extensive, distillation, insoluble, pure substance, heterogeneous. There's so many different things. Okay, it's kind of hard to keep track. So this concept map is supposed to give you sort of a visual to see how everything's related and how they're all connected. So you should have a concept map in your packet. So if you're sitting here trying to write down all this, don't torture yourself. You should have this in your packet somewhere. I think it's probably the next page, is my guess. Anyways, so this whole unit is about matter. It's about matter. And just to remember, literally everything is matter. And matter is anything that takes up mass and volume. Okay? It's got to take up mass. It's got to take up volume. And there you got some matter. So if it has mass and volume, which is literally everything. Everything has mass and volume. Everything has mass and volume. Okay. So then, on the far left here, let's talk about the types of matter. We talked about all the different types of matter, all the different types. Let me see here. Hey, Grace Bryles.
It's elements and compounds.
That's right. Those are pure substances. Now, which one's the most basic form of matter?
Elements.
You got it. And when you have two or more connected, we're talking about compounds. Perfect, Grace. That was awesome. Yes, ma'am.
Could you go a little slower? Because I can't really listen and write at the same time.
That's okay, yeah. I'll talk a little bit more about this idea. So again, elements, that's anything found on the periodic table. Your zinc, your hydrogen, plutonium, whatever. So it's the most basic form of matter. And if you have at least two different elements stuck to each other, that makes a compound. So when we were drawing pictures of these, you might see something like, oh, a bunch of circles kind of just around like that. That would be an element. And then a compound would maybe be like, oh, here's a circle stuck to a square. Two different atoms, that kind of thing. Okay, not bad. And then we talked about mixtures. Hey, Aurora, what's the kind of mixture where we can't really see the different parts? It's all evenly mixed. There's no like difference throughout. I couldn't quite hear you. Can you say that a little bit louder? There you go. Thank you. Homogeneous. Remember, homo means same. Geneous means look, so it looks the same throughout. And heterogeneous. Hetero means different. Geneous means look. It looks different throughout. Okay. And you should be able to see the different parts. So, for example, a fruit salad, you can be like, that's a strawberry, that's a grape. Like, you can see the different pieces in there. That's what makes it heterogeneous. Okay, so then we talked about mixtures. And so since mixtures, the things aren't chemically bonded, they're just sort of in the same container. Okay? We should be able to separate those using various techniques. Hey, Destiny Evans. Let's say I have two liquids in a sample. Okay, but they have two very different boiling points. What technique do you think would be a good one to use? Boom! That's what I'm talking about. Absolutely. Distillation, money in the bank there, just like the peach pop. The peach flavoring and the orange food coloring had two different boiling points. The peach flavoring left the container first. Hey, which one leaves the container first? The one with the lowest boiling point or the one with the highest boiling point? The lowest boiling point, right? Because it's going to be the one that boils first, evaporates first, it flies off as a gas first. Pretty good, pretty good. Let's see here. Brandon Pate, what if they have difference in color? How could I separate those? Chromatography, yep. I had last period, this girl's like, the chromie something thing. I don't know. Yes. Chromatography. Hey, by the way, the word chrome means color. So my friends sometimes say I dress monochromatically. It means I just kind of wear one color at a time. Mono one. So chrome means color. Okay, now let's see here. Mr. Mitchell. So one technique manipulates solubility only. One technique manipulates density and solubility. Which one's which?
Density, centrifuge, solubility, filter.
Love it, love it, love it. Love it, love it, love it. Pretty good, pretty good. So again, centrifuge, you have to have something insoluble. And they could be two different liquids. You could have like oil and water, because oil is not soluble in water. Which, a filter might not really work super well with oil and water, because, maybe oil's molecules are about the same size. But a centrifuge would be perfect for those, because their densities are different. All right, so then we get to this idea of soluble. So soluble means it can dissolve or it does dissolve. Insoluble means it does not dissolve. Okay? Insoluble means it does not dissolve. So let's not forget that. And then, lastly, a solid that falls out of solution. What was that called? I think Lacker was just talking about how much he loves these. There we go, precipitate. Yep, I poured those two samples together yesterday. That white powder formed. It fell out of solution. It was an insoluble solid called a precipitate. Yep, and this is all related because you're like, okay, this is important information for me to know, soluble versus insoluble, precipitate forms or not, and that will help me determine what kind of separation technique to use. Make sense? Alrighty. So we're back at the top. Everyone got all this stuff down here? Alright, we're back at the top. Okay, so then we talked about changes. Hey, Olivia Enders.
Yeah.
Yes. When you have a physical change, do we have a new substance or the same substance?
It's the same substance.
Yep. What's an example of a physical change?
Like density.
That's an example of a physical property, but what about a physical change?
Physical change. Oh my gosh, sorry.
You're fine.
Ripping paper in half.
Yeah, ripping paper in half. It's paper, you rip it, still paper at the end. Thank you, Ms. Enders. That was perfect. There's no new matter. Chemical, the new matter is produced in some fashion. All right, now I really want to mow some people down. All right, this is going to be a good one. Hey, Jack.
Yeah.
Oh, your mic sounds great. Hey, Jack, give me one piece of evidence that there has been a chemical change.
Gas is produced.
Yes, a new gas is produced. Not boiling, but a new gas like smoke. Love it, Jack. Okay. Now you're all trying to fumble in your minds, like, wait, what are the other changes or chemical change pieces of evidence? Because that's what I'm about to ask you. Hey, Washburn, give me another one. Yeah, some sort of odor is produced. Like, ooh, that stinks. That's probably a chemical change. Hey, Daniel, give me another one. Color change. You got it. You got it. Oh, man, the three easy ones are taken. What about the rest of them? Ben, do you know another one? Precipitate is formed. Ooh, 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 look at that. So we got color. We got precipitate. We got odor. We've got, what was the other one somebody said? Color, odor, precipitate. There's one other one that somebody said. What'd you say? What'd you say? Oh, gas produced. Thank you. That's what it is. There's another one or two. Yes? Temperature change. It gets really hot or really cold. Stickney? A substance like disappears or a new substance forms. These are kind of two sides of the same coin. Nicely done. There's one more word that we sometimes associate with chemical changes. One more word. Yes? Irreversible. There you go. It's pretty hard to reverse. It's kind of a one-way street type situation. Unlike physical changes that are usually a two-way street. Yep, pretty good. All right. Okay, you guys were on it. You were like avoiding my eye contact, but then you were like, actually, I got one right now. I was like, okay, all right. Not bad, not bad. Hey, Evie, what do we call the stuff before the arrow again? The A and B here? Ooh, nice. Nicely done. And these guys are called products. And you know, Evie, if I have 10 grams, if A plus B is 10 grams, then what will C plus C be? Love it. And that's true because the law of what, Evie? We're close. We're so close. The law of Schwender? Conservation of mass. There we go. Nice work, you two. Pretty good. Pretty good. Don't forget that's called the yield sign. Yep. The law of conservation of mass tells us, okay, if mass magically appears or disappears, okay, that didn't actually happen. It came from somewhere or it went somewhere. Okay? So if you know it can't be created or destroyed, you will look for where it came from or you will look for where it went. Like you'll know to do that if you know the law of conservation of mass. All right, and we're back up here on the final side. So we had types, we had changes, and we had properties, okay? So we had physical and chemical properties. Hey, Schwender, give me an example of a physical property. What's that? Yep, I can find out the mass of something without changing what it is. So like if I had a scale right here, be like, here's a cup. It's 3 grams. This is still a cup, okay? So as long as you can find that property without changing what it is, it's physical. Now, if I were to be like, I wonder how flammable this cup is. Here's a cup. I set it on fire. Now I have a handful of ash. That's not a cup anymore. That's a chemical property because you have to change what you have to find out the property, okay? So then we talked about another set of properties. Let's see here. Who's that? Oh, Uzama. There we go. I can see the weekend's like head just a teeny bit. Hey, Uzama, can you hear me? I can hear you. You sound like you're like super far away, but I can hear you. Hey, Uzama, what type of property doesn't change with the size? Woo! Look at you, smarty pants. Love it. And extensor does change with the size. Density is physical because you can find the density of something without changing what that something is. Density is also intensive because it doesn't matter how much of the stuff you have, density does not change. So for example, a whole golf ball and a half golf ball have the same density. Another example, a whole golf ball and a half golf ball do not have the same mass because mass is extensive. Okay? And with density, we're talking about mass over volume. Okay? The units for mass are grams. The units for volume are centimeters cubed if it's a solid, milliliters if we're talking about a liquid. Yep. Hey, Stickney, what's the density of water? You got it. 1.00. 1.00. And Mr. Pate, let's say I'm a ping pong ball and my density is 0.2. Am I going to sink or float in water? Float is correct. Density is less than 1, it will float. If the density is more than 1, it will sink. In water, that is. In water. All right, so that's our concept map there. I'll leave this up here for a second.
What is the units like under? Is that density units?
Yeah, so this is the overall unit, grams per centimeters cubed or grams per milliliter. Yep. Yep. All right. So that brings us to the big fella. Unit 2 review. Let me mention a few things about this review sheet, okay? Anything on this review sheet is fair game for the test. So any kind of question, any type of question I ask you on here is fair game to show up on the test tomorrow. That also means that anything that's not on here is not fair game. So for example, your first quiz of this unit was over conversions. Hey, take these centimeters and make them into miles, okay? That was a nice quiz. That is not on the review sheet, and therefore there will be no conversion stuff on the test tomorrow. Does that make sense? Okay? So that's how this works. Now here's what's going to happen next. I'm going to ask my virtual people if they have any questions, and if you don't, I will let you go after I talk to you. In the meantime, how about all my live students and virtual students go get your participation points right now before you forget?